Hi Jonathan, hope you're having a fantastic time as I sit here at work in cold Melbourne. Let's get going. Quadratic formula. We're going to use when we want to find the x-intercepts for a quadratic. Now we've looked at different ways. You've used your cross-bridge method. You've used your decomposition method. If you look back to our other videos, you'll see what I'm talking about there. This quadratic formula will be used or can be used when you're stuck or for ones that don't have nice factors. So this is like your magic formula. Now remember, the general form for a quadratic is this: ax squared plus bx plus c. So a in front of the x squared, b in front of the x, c stands alone. So the quadratic formula, you substitute those values into this: minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And this will always find your solutions. Now, yes, it can be used all the time, but if you can do it a little bit quicker by doing cross-bridge or decomposition, then that would be your best bet. And practice will get you there in the end. So let's put it into practice, Jonathan. Using the quadratic formula, find x-intercepts for y equal to 3x squared plus 6x minus 2. What you should always do is work out what your a, b and c value is. So a is equal to 3, b is equal to 6, c is equal to minus 2. Remember our rule, x equals minus b plus or minus the square root b squared minus 4ac on 2a. You will use it so much that you will remember it. At this stage, make sure that you are copying it down all the time so that you do remember it. Minus b, so minus 6, plus or minus, again, b squared is 36, minus 4 times a times c. 4 times 3 is 12, times 2 is 24. 2 minuses make a plus. So it's 36 plus 24, all divided by 2a. Again, 2 times 3 is 6. Let's simplify that a little bit. So we have minus 6 plus or minus the square root of 36 and 24, 50. That's 60 over 6. Now let's come over here. Although that's an answer, let's see if we can tidy that up at all. Alright, so I'm going to look at my square root 60. At this stage you cannot cancel down that minus 6 up the top and the minus 6 down the bottom. It has to be a factor. So I'm going to write the square root of 60 as 4 times 15. Alright, and I'm just going to come up here into a bit of a working column and show you that the square root of 4 times 15 is equal to this 2 times root 15, or 2 root 15. So I'm going to write that here. So minus 6 plus or minus 2 root 15 on 6. Now up the top I can take out a common factor of 2. Let's put our equal signs there. So it's 2 outside of minus 3 plus or minus root 15 on 6. And now and only now can I cancel that down with that, and that's 3. So my final answer is minus 3 plus or minus the square root of 15 on 3. So remember, Jonathan, that's minus 3 plus root 15 on 3 and minus 3 minus root 15 on 3. And you should always try and simplify as much as you possibly can. Okay, let's do one more. Again here, you've got a equal to minus 2, b equal to minus 4, c equal to 3. Our rule, x equal minus b plus or minus the square root, b squared minus 4ac on 2a. Substitute in, so minus 4 is a positive 4. Plus or minus, any negative squared is always going to be positive, so it's 16. Minus 4 times minus 2 is 8. 8 times 3 is 12, all on minus 6. Okay, 4 plus or minus 16 plus 12 is 28 on negative 6. Again, we just want to see if we can simplify that down. Remember, when you're looking for factors, you are looking for ones that, where one is a square root. So the square root of 28, and I want one that's a perfect square. So 4 times 7, where 4 is the perfect square, and the square root of 4 is 2, so it's 2 root 7. So now if I keep going with that and trying, that's an answer, but I want to simplify it as much as possible. So 4 plus or minus 2 root 7 on minus 6. Take out your common factor up the top, which is 2, and you're left with 2 plus or minus root 7 on negative 6. Okay, 2 and 3, and so you're left with 2 plus or minus root 7 on negative 3. Now that can be written a few different ways. That is two answers. It is 2 plus root 7, if you like. It's 2 plus root 7 on negative 3, or 2 minus root 7 on negative 3. Alright, so that is using the quadratic formula to get your x-intercepts. And of course, that they could be decimals. In methods, we tend not to use decimals. We tend to use the exact values. So you will probably see your answers written like that 99% of the time. The discriminant is something that we use to work out how many solutions we actually have without actually having to work them out. And the discriminant, we use a triangle as the symbol, and it's equal to b squared minus 4ac. If you take a really close look at that, you'll notice that's the inside bit of the square root for the quadratic formula. So what we're saying is if that inside bit is less than 0, it's negative, then there's no solutions. Because remember, if you've got the square root of b squared minus 4ac, you cannot take the square root of a negative number. Therefore, no solutions. If the inside bit of that square root is 0, then there is one solution. And then if the inside bit, so b squared minus 4ac is a value bigger than 0, you will always have two solutions. Putting it into practice. So again, Jonathan, always write out what your A, B and C are. So A, let's use a different colour here, we'll use red. A is equal to 3, B is equal to minus 4, C is equal to minus 2. Discriminant is b squared minus 4ac. B squared, 16, minus, 4 times 3 times minus 2. So it's 16 plus 24, and so that makes 40. That is a value which is greater than 0, so therefore we have two solutions. Alright, another one. So here A is equal to minus 3, B is equal to minus 2, and there is no C value. We're looking for the discriminant. Discriminant is b squared minus 4ac. So b squared is minus 3 squared, which is positive 9, minus 4 times minus 3 times 0, because remember C is 0. And so therefore 9 minus 0 is 9. Again, it is greater than 0, and therefore we have two solutions. So what that means that if we were sketching that graph, we'd have two x-intercepts. And one more. This time you've got A equal to 1, B equal to minus 4, C equal to 5. Again, discriminant equals b squared minus 4ac, and this time it's 16, take away 4 times 1 times 5, 16, take away 20, and we end up with a negative 4. This is less than 0, so therefore we would have no solutions or no x-intercepts. So your graph would probably look something like this. It would be above your x-axis, or it would be below your x-axis, but it would not be cutting your x-axis. Let's put all of this together. Now, Jonathan, this question says to sketch the graph of y equal to 2x squared plus 4x minus 3, labelling all the significant points. So significant points would be talking about y-intercept, x-intercept, and turning point for a quadratic. So let's start with I'd like to start with the trend. And we've talked about that before. Is it a positive or a negative hyperbola? We're looking for what's in front of the x squared, and it's a positive, so therefore our graph will be an upright parabola. Y-intercept, you're going to let x equal to 0. Letting x equal to 0, you get y equal to 2 times 0 squared plus 4 times 0, take away 3, and obviously y is negative 3. And we know that we can read that off from our equation much easier. So when x is 0, y is minus 3. All right, next bit, let's find our x-intercepts. And I'll come up here and do that. X-intercept, let y equal to 0. Alright. So we've got 0 equals 2x squared plus 4x minus 3. Now, if we can, it would be really nice to be able to do maybe cross-bridge method or decomposition, but I can tell you here that it does not factorise any way other than using your quadratic formula. So I'm going to use the quadratic formula here to get my x-intercepts. We know a is 2, b is 4, c is minus 3, and we know x equals minus b plus or minus the square root of b squared minus 4ac on 2a. I'm going to substitute in now, and I get x is equal to minus 4 plus or minus the square root of 16 minus 4 times 2 is minus 8 times minus 3 is positive 24 over 2a, which is 2 times 2, which is 4. So tidying that up, I get minus 4 plus or minus the square root of 40 on 4. And again, taking out a common factor there, Jonathan, 40 is the square root of 4 times 10. So it's 2 root 10. So I'm going to take out a common factor of 2. And I've got minus 2 plus or minus the square root of 10 on 4. That goes. So I've got minus 2 plus or minus the square root of 10 on 2. Now, there are your two answers. If I wanted them as decimals, I'd put that into my calculator and I'd get 0.58 and negative 2.58. So I think this question asked you to give them to 2 decimal places. So they are my x-intercepts, if you like. Now the last thing that I need to find is my turning point. Now you can, remember we talked about the fact that your turning point was slap bang in the middle of your x-intercepts, but we also talked about at one stage that to find the turning point you can use this rule, x equals minus b on 2a. That will give me my x value. So here x would be equal to minus b, which was minus 4, over 2a, which is 2 times 2 is 4, so that gives me a negative 1. So that's my x value of my turning point, and I'm going to substitute that into my equation, and my equation was y equal to 2x squared, so y equal to 2 times minus 1 squared plus 4 times minus 1, take away 3, and you tidy all that up and you get negative 5. So my coordinate for my turning point is negative 1 and negative 5. Now you've got enough information to sketch the graph. So we draw up our axes. I've gone up in ones on both the x and the y axes. I'm going to plot some of my points here. I know my y-intercept is at 0, minus 3. So 0, minus 3. I know my turning point is negative 1, negative 5, which is there. Okay, and I know the trend there. Alright. Nice smooth, don't like that. Nice smooth line, Jonathan. 0.58. It'd be around about there on my graph. So 0.58, comma 0, and the other one negative 2.58. So negative 2.58 and 0. So there's my points. I'm going to try and draw a nice graph here. You should be using a pencil because that gives you greater control over your graph. So I don't really like mine. It shouldn't be doubling up like that. Okay, it's just a little bit harder on this iPad to get a nice looking curve. But I think you understand what I'm talking about there. So with a lot of these things, x-intercepts, there's a few ways that you can get them. We've looked at the quadratic formula today. Turning point, again, there is a few ways that you can get that. We've looked at using minus b on 2a today. The y-intercept pretty much is read off the equation when it's in general form, and they are the three things that you need when you are sketching a graph. So I hope this helps you to complete exercise 7E.